Here's a list of formulas that you'll need to answer some sample questions for the gas loss test. The two significant formulas are the combined gas law formula. The first formula there, PV equals Boyle's law. The second one is Charles' law, followed by Gay-Lussac's law. But the significant ones are the combined gas law. See, it's a combination of all of the different gas laws in one formula. And then the other one is PV equals nRT, and this is the ideal gas law, and this is the only one that takes moles into consideration if you're having to solve for the number of moles. The reason I say these two are the significant ones is if you only have PV and PV and you don't have temperature, if you just leave temperature out of the equation, you end up with exactly Boyle's law. Once again, also, if you didn't have pressure in the problem, then you'd have V over T equals V over T, and you'd have Charles' law. If you didn't have volume in the problem, all you'd have left would be P over T equals P over T, and therefore you'd have Gay-Lussac's law. So this would let me use this law, and if I don't have the variable, I just leave it out of the equation. Be careful, don't use a 0 or any other number, you just completely leave it out. Otherwise, you can use the law that applies to each problem. So let's talk about the relationship of a gas in an expandable container. The test will say expandable container. So go ahead and think of the lab that we did with the balloon. Is cooled. What happens to the volume of the gas? Here's a hint. Whatever happens to the temperature, that's what the other variable does. So you go and look and see, this says cooled. To me, that means temperature going down. If whatever happens to the temperature happens to the other variable, temperature going down means volume going down. So it will decrease because temperature down equals volume down. If the pressure surrounding a gas in an expandable container is decreased, what will the volume do? You'll notice that there's no temperature involved. When there's no temperature involved, the variable does the opposite thing. So it will increase because this is pressure down. Pressure in an expandable container decreased. What will the volume do? The opposite, which is increase. What change would cause a decrease in the pressure of a contained gas? So look at your other two variables. They're asking about pressure. That leaves us to consider both temperature and volume. If we think about temperature, we know it's going to be the opposite. So what would cause a decrease in pressure? That would be also a decrease in temperature, and the opposite of that in its volume, so an increase in volume. So temperature down, pressure down. So this is asking what would cause a decrease in the pressure? Temperature going down. The other option would be what would cause a decrease in the pressure? The opposite thing in the volume. So pressure down, volume up. Pressure goes down if the volume goes up, because when temperature is not involved, the opposite thing happens.